Hello students. Now in previous video we have completed the inclusion exclusion principle. Now here let us see the pigeonhole principle. The pigeonhole principle. Now what does this exactly? Now let us see first of all, if A is average number of pigeons, average number of pigeons per pigeonhole, then first thing, some of the pigeons or some pigeonholes, some pigeonhole contains at least, ceiling of A. This is what? A ceiling of A. Ceiling of A pigeons. Second thing is that some pigeonhole contains at most floor of A, this is what? A floor of A pigeons. These are two important principles of the pigeonhole principle. Now what does this exactly? Let me explain with the help of example. Let us take example. If we have 11 pigeons and 4 holes. So now we have 4 holes. Now let me prepare a box here. Suppose it has 4 compartments. These are our 4 holes and 11 pigeons with us. So suppose first pigeon will be first pigeon is here, second will be here, suppose third will be here, fourth will be here. Again suppose fifth will be here, sixth is here, seventh is here, eighth is here, 9 is here, 10 is here and 11 is here. Now what does this gives? This gives now 3 compartment or 3 boxes. We can say boxes also then, or the holes. 3 holes consist 3 pigeons while 1 hole consists only 2 pigeons. So what does this exactly? Now we have 11 pigeons and 4 holes. So let us find out the value of 11 divided by 4. It is 2.75. Now this, what is the ceiling of 2.75? Ceiling of A, I am saying here in the first principle. So what is ceiling of 2.75? Ceiling of 2.75 is the integer greater than or equal to 2.75. So it is what? 3. It is 3 here. So as this is 3, so what does this say? A is average number of pigeons. So 11 pigeons are there per pigeonhole. Then some pigeonhole contains at least ceiling of A pigeon. So clearly here 3 pigeonhole consist 3 pigeons, while what is the floor of 2.75? Floor of 2.75 is the integer which is smaller than or equal to 2.75. So that is what? 2. Now one of the pigeonhole consists 2 pigeons here. So or it contains 2 pigeons. So at the same time both of the principles are true. That is what the pigeonhole principle. In any one of the example, at least ceiling of A pigeons in some of the pigeonhole and at most floor of A pigeons in some of the pigeonholes. These are what? The remaining pigeonhole consist this at most and the previous one consists at least. This is the part. So in every case both of them are true always. Now let us see a very important theorem here. Let me give the statement of the theorem. Simply the statement of the theorem we have to see. We don't want the proof of that one. We have to use that one while solving the examples. So the theorem says these are or there are n pigeonholes, then there are, we should write, there are n pigeonholes, then the number of or the minimum number of pigeon required to guarantee that some pigeonhole contains at least k plus 1 pigeon, in kn plus 1 is what? Kn plus 1. Now what are they here? If we see just like a previous one, now n pigeons are there and how many holes are there? Kn plus 1 holes are there. So kn plus 1 pigeons are there and n holes are there. So if we find this value, that the ceiling of A, what is ceiling of A here? Kn plus 1 upon n. If we are finding this, what does this? This is nothing but this is k plus 1 upon n. So ceiling will be what? Whatever the fraction will get here, that is what? Greater than or equal to that number. The integer value greater than or equal to that one. So obviously it is what? K plus 1. Just like here, look at here, 2.75 is here. So greater than or equal to that one. So it will be what? 3. That is the integral value. And this floor means what? The value of integer which is what? Just less than and equal to that one. So less means what here? 2. Similarly here what we get? K plus 1 upon n having the ceiling value is what? K plus 1. So clearly if n pigeonholes are there, then the minimum pigeons required to guarantee that some pigeonhole contains at least k plus 1 pigeons. Similarly here 3 pigeons are in 3 boxes and 2 pigeons are in 1 boxes. So pigeons required for each box consists k plus 1 pigeon are how many? Kn plus 1. Fine. Kn plus 1. So this one we are using for while solving the examples. Now let me take the examples. Before going towards example, let me give one more note to you. Note. If you won't understand this theorem, then this note will help you. The note says, if we have m items or objects and n containers, then number of pigeons in each hole are how many? These one. This is what? M by n. Number of pigeons, but these are which type? At least these one. At least this m by n is here. Fine. Now let us see the example. Now the example. Suppose 401 letters are distributed in 50 apartments. Now same thing, we will find this value 401 letters with us. So these are what items with us, and 50 apartments with what n containers, just like that. So we will find this value 401 upon 50. So the ceiling of that one, if you find, it will be 8 point, this value will be 8 point something. So what can we say? We can distribute at least 9 letters, in each, or at each home, at each apartment, I can say, at each apartment, or we can distribute at most what, 8 letters, at each apartment, So this is what, greater equal 9 or less equal what, 8. That is the case, as I said in the previous principles. So the answer of this one will be as such, at least 9 letters in each apartment, or at most 8 letters in each apartment. Now the next example is that in a class of 62 students, what is the minimum number of students required to ensure that two students have their birthday at the same day. Now here 62 students. Now totally, if the question is for the 2 students have the birthday at the same month, if such a question is there, then we will divide 62 by what, 12. That time it is 5 point something. So we can say at least 6 students are there having this birthday in the same month, or at most 5 students having their birthday on the same or in the same month. Now here we have to determine the birthday at the same day. So how many days are there? Let me take 366. Why? Because in leap year we have total number of days are 366. Now we can select such a 366 students here having their birthday on different days. So here, but the students 366 plus 1. So that are how many? 367. So here this one student and one more from these one. Togetherly there are 2 students. At least 2 students are here having their birthday on same day. Now the same question can be solved using what? The theorem as we have written. Now we want 2 students. We have to select how many? 2 students having their birthday on same day. So here k plus 1 is equal to what? 2. according to theorem, the k plus 1 is equal to 2. Means we have to put these many pigeons in 2 pigeons in k plus 1 places. Fine. So that gives the value of k is equal to what? 1. But n is equal to how much? 366. N is equal to 366. Therefore, what is kn plus 1? We can determine kn plus 1, and that kn plus 1 is what? Our answer. Minimum number of students that guarantees the minimum number of students that those guarantee that those ensure that the 2 students have their birthday on the same day. So k is equal to what? 1. What is n? 366 plus 1. So it is how many? 367. So what can we say? Minimum 367 students we require. Minimum 367 students we require to satisfy the condition. To satisfy the condition. Is it okay to you? Now the next example is that, let me take the next one. Minimum number of cards we have to draw from a deck to guarantee that 4 cards of same suit. Now, do you know the cards? If you don't know the cards, there are total 52 cards and 4 different suits are there. So now here, what is k plus? We can solve this one by our arbitrary choices. So now 4 cards we have to select. So now there are 4 different types of suits. So that are what? Heart, square, S, and one more. So let me take it as X. I don't know, I won't remember the name of that one. Okay, fine. So now here the heart, suppose the 4 cards we have to select. So they may be as such. Again, suppose next time also they are as such. Now 4 cards of same suit. Now one more card, it may be of this suit, of this suit, of this suit, or of this suit. So how many are they total? These are 12 plus 1, this one. So total are how many? 13 cards we need to select. Minimum 13 cards we have to draw, so that it guarantees that the 4 cards are of same suit. Okay, and the same thing we can solve using the theorem. What the theorem says? K plus 1 is equal to what? 4. So that gives k is equal to what? 3. 4 cards we have to select. So k plus 1 is equal to 4. So k is equal to 3. Now what is n? N is equal to number of suits. Number of suits are what? 4. That is what? This is number of suits. Okay. Now therefore, what is kn plus 1? Kn plus 1 is what? 3 multiplied by 4 plus 1. That is how much? 13. So minimum 13 cards. Therefore the answer is minimum 13 cards we have to draw. From a deck to satisfy the condition. Okay. Now let us take the next example. Now suppose the example is that a box contains 2 6 red, 8 green, 10 black, 11 yellow and 12 white balls. 12 white balls. What is the minimum? What is the minimum number of? What is the minimum number of balls we have to select from box to guarantee that 9 balls of same color. 9 balls of same color. Now here, how many colors with us? There are total 5 colors. Now 6 are what? Red color, 8 are of green color, 10 are what? Of black color, 11 are of yellow color and 12 are of white color. Now if we draw all 6, then it doesn't satisfy our condition. What does the condition? 9 balls of same color. Again, if we draw our green, all are green, then also it doesn't satisfy our condition. If we draw 10 black, then it will satisfy the condition. So it will be satisfy the condition from these ones simply, that the 9 balls are of same color. But now it is not possible that always we will get black, yellow or white. So in place of that, now let me consider, suppose we have 6 red color, I will select. Suppose 8 green colors, I will select. 8 black colors balls, again 8 yellow color balls and 8 white color balls if we select. Now again one more ball, suppose I will select. Now that one more, it won't be red color, it won't be green color, but it may be of black color or yellow color or white color. So if it will taken with this one, then it will satisfy our condition, that it guarantees that the 9 balls are of same color. So total how many balls we have to select in that case? These are how many? 6 plus 8 4 is 32 plus 6 will be 38 plus 1. So how many are they? 39. So here what? 39 balls, minimum 39 balls we have to select. We have to select so that the condition is get satisfied. Now let me take 2 more example for this one, so that you will get this thing clearly. Now suppose the next example is that there are 8 branches in an engineering college. In an engineering college, okay, what is the minimum number? What is the minimum number of students? What is the minimum number of students? What is the minimum number of students we have to select? We have to select from a college to guarantee that 7 students from same branch. 7 students are from same branch. Now what is the condition here? N is how much? 8. N will be the number of branches. What is k plus 1? K plus 1 means what? The 7 students. So this value we want. Yes, so k plus 1 is equal to 7. So that gives k is equal to what? 6. So Kn plus 1 will give us the number of students we require to select. So Kn plus 1 is how much? 6 into 8 plus 1. So that is how much? 49. Therefore, what will be the answer? For minimum 49 students. Minimum 49 students we have to select to satisfy the condition. To satisfy the condition. Okay. Now then let us take one more example. We have to form a committee in our college. Suppose we have to form a committee in our college. The committee is valid. The committee is valid if there are 8 students of first year. 8 students of first year or 7 students of second year. 7 students of second year or 6 students of third year. 6 students of third year or 5 students of post graduation. Suppose of 5 students of what? Post graduation. So any one of the thing will satisfy, then we can say yes, the condition is set. This committee is valid. There are 8 students of first year. So suppose let us select 7 students from first year. Now what? 7 of second year. So let me take 6 of second year. Next one, 6 students of third year. So let us take 5 of third year. Then 4 of post graduation. So now suppose let me add one more student is here. Then this one is added to this 7. Either it may be of first year, it may be of second year, it may be of third year or of post graduation. Fine. So if it is of first year, then it satisfies the condition of first year, and or is here. So any one of the conditions should satisfy here. So this is get satisfied. So what is this addition? This addition is what? 23. So this addition is 23. So the answer is what? The answer is here. We have to select how many? 23 students from our college. From our college to get a valid committee. Now this is about the pigeonhole principle. Now in next video we will start the permutation combination. Okay, thank you.